next one is eigenvector. In the previous problem, I left one eigenvector for lambda is equal to plus I. That is A minus lambda I into x equal to O. Lambda stands for now small I. Subtract I from the diagonal elements. We will be getting minus I, minus 1 plus 1 minus I. Because 2 by 2 matrix, take that column is xy. Right side 0, 0. Convert into equations. Minus x minus y is equal to 0, equation 1. And 2, x minus iy. I told you already in the previous problem, in that when finding eigenvector for a 2 by 2 matrix, the corresponding equations must coincident. Or coincident, I already shown in the previous case. Now one of these equations expressed in the form of one side x value, other side is y value. That is called simultaneous equations form. One implies minus ix equal to y. This implies x by 1 is equal to y by minus I, or x by 1 by minus I is equal to y by 1. That is 1 by I is minus I, so x by I is equal to y by 1, etc. Depending on the options only, you express like this simultaneous form. What is that simultaneous means? Expressing on each side one unknown only. Okay, on each side one unknown along with the denominators. Okay, no pre-multiplications. Therefore, E vector, say x2, depending on the options. Okay, in the first representation we got 1 minus I. In the second representation, that is I put R I1. Okay, or if these values, if these vectors are not matched in your options, then multiply by a number, non-zero number k. See that option, because I told you, I shown you in the first problem, if x is an eigenvector, then k into x is also eigenvector for the same lambda. The next one is third one, which is given 2006, 2 marks. The E values, that means eigenvalues, and corresponding E vectors of a 2 by 2 matrix. Matrix is not given because already eigenvalues and vectors are given by lambda 1 is equal to 8, lambda 2 is equal to 4, x1 is equal to 1 1, x2 is equal to 1 minus 1. The matrix is here. Options are given, but I am not giving because fill in the blanks also the questions coming. So vectors generally denoted by x notation, sometimes v notation, l notation, any notation. Okay, solution, because we are going to find the matrix, 2 values are given, so it is a 2 by 2 matrix, standard notation A, B, C, D. Now while finding eigenvector, with options or without options, depending on the procedure. Okay, A minus lambda into x equal to 0, finding eigenvector, that is simplified. I shown you Ax is equal to lambda x. Okay, using the, depending on the options, take proper procedure. Sometimes we are finding eigenvector using the procedure A minus lambda into x equal to 0. Sometimes I am going to take Ax is equal to lambda x, depending on the options. So, okay, that means depending on, taking time and number of steps, less number of steps. Due to these reasons only, we are using one time that procedure, other time this procedure. Okay. Now, we know that KT stands for know that AX is equal to AX1 is equal to lambda 1 x1 and AX2 is equal to lambda 2 x2. Why I have taken this notation? Because already eigenvectors given, eigenvalues are also given. Okay. In such cases, don't take the procedure for finding eigenvector. Don't take that formula a minus lambda into x equal to 0. If you take, then again you reduce that, you bring that step into like this only. Okay, no use only. Okay, now x1 is first eigenvector, lambda 1 is first eigenvalue. So what is our procedure for eigenvector? A minus lambda I into x. Actually, this is the original procedure, but sometimes this procedure, this simplifies to ax is equal to lambda x. This takes less time, less number of steps also, depending on the options also. Okay, with options or without options. Now, this is a, b, c, d. Okay, into x1. That is 1, 1. This is lambda 1. What is lambda 1? 8 into 1, 1. And this is a, b, c, d into x2. 1 minus 1 is equal to 4 into 1 minus 1. Now, after multiplying and equate the corresponding elements, because LHS equal to RHS, that is two matrices are equal means corresponding elements are equal. Okay, both LHS and RHS are in the form of column matrix only. So this simplifies to a plus b is equal to 8, c plus d is equal to 8 after multiplying and then equating correspondingly in the right side. So let us say this is equation 1, this is third equation because CD. On the other side, this is a minus b is equal to 4, c minus d is equal to minus 4. Let us say this is equation 2, equation 4. So why I took like this? Because a, b are together, that is 1 and 2. CD equations respectively or correspondingly or consecutively, whatever the word you use. First two letters AB, that's why AB equations I have taken 1 and 2. CD are the next two letters, that's why I taken the two equations numbered by 3, 4. Solving, we get A is equal to 6. That is just adding 2A is equal to 12, A is equal to 6, then B is equal to 2. And here also C is equal to 2C is equal to 4, C is equal to 2, D is equal to 6. Therefore, the matrix is 6, 2, 2, 6. Another different example. Which is given 2010, 2 marks. An E vector, that is eigenvector, of the matrix P is equal to 1, 1, 0, 0, 2, 2, 0, 0, 3 is options given. A minus 1, 1, 1 transpose, B 1, 2, 1 transpose. Transpose of row matrix is nothing but column matrix, that's why eigenvector representation is in the form of column. 1, minus 1, 2 transpose D. Two, 1, minus 1 transpose. Now here options are given. Then you see which method is simplest. Directly taking Ax is equal to lambda x or A minus lambda into x equal to 0 procedure. Finding eigenvector. But here matrix is given. Instead of A matrix it is P notation given. But no eigenvalue is mentioned. But the question requires one of the eigenvectors. An eigenvector. Now observe, P is upper triangular matrix, below the diagonal elements are 0. Now one of the properties I am going to explain after this problem, properties I am going to give, that is called shortest method for some problems, eigenvalues. Whenever it is a diagonal matrix, scalar matrix, identity matrix, upper triangular, lower triangular matrix, in such cases eigenvalues are nothing but it's just diagonal elements only. Or take any of these definitions matrix example, use your characteristic equation procedure which I have done 3 problems already, okay, then find equation in lambda, solve it, you will get lambda values, just diagonal elements, only for scalar, identity matrix, diagonal matrix, triangular matrix, okay. So therefore E values are lambda is equal to 1, 2, 3, okay, just diagonal elements. Or if you are not satisfied, use your original procedure, characteristic equation, det A minus lambda is, subtract lambda from the diagonal elements, then evaluate, you will get again 1, 2, 3 only. Okay, here no eigenvalue is mentioned. In such cases option method is useful. Option means taking one by one option as capital X and find the product first of all LHS. What is the procedure for eigenvector? A into x is equal to lambda x. LHS is A into x. RHS is lambda into x. So A is nothing but P matrix, x is nothing but your one by one option. So find the product in lambda into x is getting or not. Okay. A, option A. What is x? Minus 1, 1, 1 transpose, which implies P into x. Instead of A, it is P given. P matrix 1, 1, 0, 0, 2, 2, 0, 0, 3. Into x means minus 1, 1, 1. This simplifies to 0, 4, 3, which is not equal to lambda into x. What is this lambda? 1 or 2 or 3. That means this value is not equal to 1 into x or 2 into x, 3 into x, because we got 3 values, eigenvalues. Okay. Next, option B. X is equal to 1, 2, 1 transpose, implies P into x. That means 1, 1, 0, 0, 2, 2, 0, 0, 3 into x, 1, 2, 1, multiplying and then simplifies to, this is 3 and this is 6 and this is 3. In this I am getting 3 common, keeping outside, and then, so 1 to 1 is nothing but the given vector x, and 3 is one of the eigenvalue we got, even though eigenvalue is not mentioned in the option B. Okay. Therefore option B is E vector. Okay. Options A, C, similarly you can check A, C, D are not E vectors. Similarly you can check C and D. So sometimes option method takes less time. Sometimes original procedure A minus lambda into x equal to 0, that takes less time. But here no eigenvalue is mentioned. That's why I have used this method. Finding the product first of all A into x, that is P into x, and in the option B we got the one of the lambda values into the x value. X is nothing but each option. Properties. There are minimum 10 to 12 properties, please by heart, which are useful for 1 mark questions. Sometimes problems also like this upper triangular matrix without characteristic equation. I wrote direct eigenvalues answers. Please by heart the coming properties. First one, if X is an E vector of a matrix A, then K into X is also an E vector for the same E value lambda of A, for the same or for the corresponding. Okay, I already shown you in the first problem of eigenvalues eigenvector K into X, K into 1 to 2. Okay, K not equal to 0, please remember. Next, E values of a unit matrix, that is identity matrix, diagonal matrix, scalar matrix, triangular matrix are equal to just the principal diagonal element. Are all equal to just the at least one E value of a singular matrix is 0, and E values of a non-singular matrix that is lambda not equal to 0. 4. Very, very important this one. Sum of the E values, that means eigenvalues, of a matrix A is equal to sum of the principal diagonal elements, that is trace A, and product of the E values is equal to determinant A. See, this I already verified, and this is I verified the last problem before this properties. Take any 2 by 2, 3 by 3 matrix using these definitions. You find your original procedure for characteristic equation. You will get lambda values are nothing but diagonal elements. Next, at least one eigenvalue of a singular matrix is 0. Today's first problem, that is, we got lambda is equal to 0, 3, 15. One of the eigenvalues is 0. Check that matrix is singular or not. Singular means determinant equal to 0. Today's first eigenvalues problems, the corresponding matrix, if you find determinant, you will get 0 only. Okay. And today's second problem, we got minus I comma I. All are not equal to 0. So that matrix is non-singular. That is, I told you today's second problem, 0 minus 1, 1, 0. If you find determinant not equal to 0, non-singular. Next, sum of the eigenvalues of a matrix is equal to sum of the principal diagonal elements, and the product of the eigenvalues is equal to determinant A. Okay. What is our today's first problem? A is equal to 8 minus 6 2 minus 6 2 7 minus 4 minus 4 3. Okay, lambda values we got 0 3 15. Okay, now what is sum of the eigenvalues? 0 plus 3 plus 15 18. Sum of the diagonal elements, that is trace of the matrix, 8 plus 7 plus 3 18. Take any matrix. Okay, now what is determinant A of this problem? 8 into 7 into 3 21 minus 16 5 minus of minus 6 plus 6 into minus 18 plus 8 minus 10, the last element in the first row, plus 2 into 24 minus 14 10. This simplifies to 0. What is the product of the eigenvalues? 0 into 3 into 15 0. Like that any matrix you can check after finding eigenvalues. This fourth property. Okay. Next, fifth one. Eigenvalues of a real symmetric matrix are all real numbers. Eigenvalues of a real skew symmetric matrix are either 0 or purely imaginary. Purely imaginary. Eigenvalues of a real orthogonal matrix are of unit modulus that is have an absolute value 1. Copy. Now let me verify this one. Real symmetric matrix. What is our today's first problem? Eigenvalues 8 minus 6 2 minus 6 2 7 minus 4 minus 4 3. If all elements are real numbers, that is a real matrix. First row equal to first column, second row equal to second column, third row equal to second column. So it's real symmetric matrix. What we got? Eigenvalues all are real numbers, 0 3 15. Okay. Next, eigenvalues of a skew symmetric matrix are either 0 or purely imaginary. Purely imaginary means I, 2i, I by 2, root 2 into I, that is called purely imaginary example. Okay, what is our today's second example in eigenvalues chapter? 0 minus 1 1 0. In this what we got? Lambda values, eigenvalues minus I comma I, purely imaginary. Okay, that is verified. Similarly in some problems either 0 or purely imaginary or both also. Okay, now the third one is eigenvalues of a real orthogonal matrix. This is an orthogonal matrix. If I say this is A, here A into A transpose is equal to I is equal to A transpose into A. You can check later. Okay. Now what we got? Lambda values minus I. What I told here are of unit modulus. Unit modulus means the modulus of eigenvalue is equal to 1. Length of the eigenvalue is 1. Modulus means length. Okay. So here mod lambda how much? Mod plus or minus I. Modulus of a complex number is root over real part square plus imaginary coefficient square. That is I coefficient square. What is mod x plus iy? Complex numbers root over x square plus y square. Mod x plus or minus. So this gives 1. That is called have an absolute value 1. Okay. So the second problem of today's class is eigenvalues, eigenvectors both real skew symmetric and real orthogonal matrix. Okay. Now the next one is, the very important one is, if lambda, very important, is an E value of A, then first one, lambda square is correspondingly, I am giving, just observe, is an E value of A square matrix. Lambda cube is E value of A cube, so on. Lambda power m is E value of A power m matrix 2. 1 by lambda is E value of the matrix inverse if lambda not equal to 0, that is determinant A not equal to 0. 3. Determinant A by lambda is E value of the matrix adjoint of the given matrix A 4. Lambda plus or minus k whole power m is E value of the matrix A plus or minus ki whole power m. Okay, where this value not equal to 0. M is a positive integer. For negative integer, that number, inside number, the base number should not be 0, because 0 inverse does not exist. Okay. Just see, correspondingly you remember square for the, suppose A is the matrix, eigenvalue also given. Find the eigenvalues of A cube. It doesn't mean that finding A square and then A cube and then characteristic equation, all these things not required. Or you verify using that method by original method also. Original method means after finding A square A cube, find characteristic equation. This is the method, properties method also. Both give same answer. For time saving purpose only. Okay. So sometimes eigenvalue is given, matrix A is not given. Find the eigenvalues of A power 10. Okay. This is the property, helps a lot. Correspondingly, A square lambda square, A cube lambda cube, A power m lambda. A inverse means reciprocal of A. So reciprocal of lambda is 1 by lambda. So that denominator not equal 0. That means the inverse exists for determinant not equal 0, non-singular matrix only. Okay. Now determinant A by lambda is an eigenvalue of adjoint A matrix. Please remember. Now this is lambda plus or minus k whole to the power m. Lambda plus or minus k raised to m is eigenvalue of correspondingly. Lambda goes to A, k goes to k, 1 into 1. K can be written as k into 1. 1 goes to I, because identity matrix, what are diagonal elements? 1, 1, 1, 1, 1. I told you already previous property. Eigenvalues of a unit matrix are all equal to diagonal elements. What are the diagonal elements of unit matrix? Ones. So that's why this is going to correspondingly. Okay. Please by heart all these properties. If lambda is an eigenvalue of a real orthogonal matrix, then 1 by lambda is also its E value. See, whenever for orthogonal matrix, if you get one eigenvalue, then reciprocal is also eigenvalue. Just verify. Today's second problem, what is this? 0, minus 1, 1, 0. So this is OM. OM stands for orthogonal matrix. You verify A into A transpose is equal to I. In this problem, we got lambda minus I, I. What is 1 by lambda? 1 by minus I and 1 by I. What is 1 by I? minus a. So this becomes I minus a, which are nothing but previously. Whenever lambda is an eigenvalue, its 1 by lambda is also eigenvalue of the same real orthogonal matrix. Okay. Next, 8. If an eigenvalue lambda is repeated m times, then we may or may not get m linearly independent, very important, this one, E vectors. I told you linearly independence. Okay, that means suppose lambda is repeated 3 times, we may get 3 linearly independent vectors or less than 3 linearly independent vectors. Linearly independent, I shown you the procedure also. Okay. Next, if an E value is repeated m times, if an eigenvalue lambda is repeated m times, then corresponding number of linearly independent eigenvectors is n minus r, which I already shown you. N linearly independent vector in the previous chapter is linearly independent solution. In homogeneous system I gave n minus r. Same procedure, only the matrix yesterday is A matrix, here A minus lambda I. Please by heart these properties. First problem, which is given 2007, the number of Li linearly independent Eigen E vectors, E stands for Eigen, of 2102 is R. Okay, here no eigenvalue is mentioned, but it is a 2 by 2 matrix. A is equal to 2102. Here below the diagonal matrix is 0, so this is upper triangular matrix. I gave one of the properties, therefore E values are lambda is equal to just diagonal elements. Okay, so this is repeat how many times? 2 times. Now if an eigenvalue lambda is repeated m times, what is the procedure for finding linearly independent eigenvectors? Number of linearly independent vectors, n minus r. Okay, just go back to here. N is order of matrix A and r is rank of the matrix A minus lambda I. All of you please come back to this point. The rank R is nothing but rank of the given matrix A, yesterday's chapter. Now this in this chapter A is nothing but A minus lambda I. N is stands for order of the matrix. Okay, number of unknowns also. So here N is equal to order of the matrix 2. R is equal to rank of A minus lambda I. What is lambda? 2. A minus 2i means subtract 2 from the diagonal elements. 0, 1, 0, 0. So, is in already row echelon form. See, this is only one first row. This is the first non-zero element circled, and below the diagonal 0. That is called, I already told you yesterday, 6 problems, row echelon form. So what is the rank now? Only one non-zero element according to row echelon form. Therefore, n minus r is equal to 2 minus 1 is equal to 1. Linearly independent. Li stands for linearly independent. E vector means eigenvector. For that repeated quantity lambda is equal to 2 comma 2. Just formulas only. Only the notation. Yesterday's is Ax. Here A minus lambda I. A is replaced by A minus lambda I. There I told linearly independent solution. Here linearly independent vectors. Vector is nothing but eigenvector. Eigenvector is nothing but solution satisfying A minus lambda I into x equal to 0. R is nothing but rank of the matrix A minus lambda I. N is nothing but order of the matrix or number of unknowns. Number of unknowns corresponds to yesterday's chapter. Order of the matrix is this chapter, square matrix. Second example. This is given 2012 2 marks. One eigenvalue of the matrix A is equal to 2, 7, 10, 5, 2, 25, 1, 6, 5 is minus 9.33. Full stop. One of the other E values is A 18.33, B minus 18.33, C 18.33 minus 9.33i, D 18.33 plus 9.33i. This is also using properties only. Solution. Given one E value, say lambda 1, value is minus 9.33. Because of 3 by 3 matrix, we have to get 3 eigenvalues, but it is already given 1 eigenvalue. So we have to find 2 other eigenvalues. Using characteristic equation method, it takes a lot of time. That is 25 number is there. Okay. So in such cases, you find determinant. Okay. Now, determinant A is equal to, because of 1 mark, 2 marks question only. Okay. 2, 7, 10, 5, 2, 25, 1, 6, 5. How much? 2 into 10 minus 150. That is minus 140. Minus 7 into 25 minus 25. 0. Plus 10 into 30 minus 2, 28. So 280 minus 280, 0. So therefore A is singular. Whenever a matrix is singular, I gave the properties, one of the E value is 0. So just say lambda 2. Okay, one of the E value is 0, say lambda 2. Now lambda 3 is equal to question mark. Okay. Third eigenvalue. Lambda 2 is 0, we got by determinant equal to 0. One eigenvalue is given. We know that properties, sum of E values is equal to sum of the diagonal elements, that is nothing but trace A. What is sum of the eigenvalues? Lambda 1 plus lambda 2 plus lambda 3, because 3 by 3 matrix. What is sum of the diagonal elements? 2 plus 2 plus 2? 9. Already lambda 1 given, lambda 2 we got, lambda 3 we are going to find. So therefore lambda 3 is equal to how much? 18.33. This is the answer. Third one, using properties. The E values of a 3 by 3, just using properties only, these problems are 1, 2, 3. Lambda 1, lambda 2, lambda 3. First bit, find 1. Trace of the matrix A square plus A inverse plus adjoint A. Second bit, determinant of the matrix A square plus A inverse plus adjoint A. Therefore